Well, it is 9:25, so let's go ahead and get started. Okay. OMY, ODE. All right, so this is a question taken from the ACT that has you use trigonometry. So I'll give you 3 minutes to try this one, and then we'll go over it. All right, so for this problem, you should label your triangle based off of this angle right here. So this would be the opposite side, the adjacent side, and the hypotenuse. To find out our angle, then, we should use our formula that the tangent of an angle is the opposite over the adjacent. So for our problem, then, the tangent of the angle would be equal to 8/3. And then to solve that, you get the tangent inverse of both sides, which gives you the answer C, which I think no one got. But I have a feeling that's probably just from mislabeling the opposite and adjacent or what have you. Does this make sense how we get how I got this?
Yeah.
Okay, sweet. Yeah, to be honest, the only reason why we have to use tangent to solve for this angle is because that's the only answers they give us in the answer key. Really, if you have all three sides, you can choose which one you want to use, like side, cosecant, what have you. But not this time. All the answers are in terms of tangent. All right, so today what we're going to learn is how to use our trig identities to solve for other, like, so I'll give you one trig function and then you'll use your identities to find the other 5 or specific ones we list. And then the other thing is to do trig identity proofs, which is kind of challenging, but it's not so bad, I think. We'll see. That's one of the harder things we've done this semester. Okay, so you will need to put all of this into your notes by hand. Don't just take a picture. You will want all of these in your notes by hand because how easily you find these problems coming up basically is determined by how well you have these memorized. And the act of writing helps you create stronger and more numerous neural connections in your brain between the problems we're talking about and the solutions, the concepts that we're trying to learn. So again, I will highly encourage you to actually write all of these down. The reciprocal identities, I think we already know. The sine of an angle is equal to 1 over the cosecant, and cosecant is equal to 1 over sine, because those are reciprocals of each other. Same goes for cosecant and secant. Same goes for tangent and cotangent. To be honest, you won't use these top 3 very much. These last 3 are you're going to use frequently. You use these a lot, not only in this class, but in your future classes too. I don't think the quotient identities should be too shocking to you. I mean, these follow directly from those definitions that we had at the start of class. If the sine of any angle is the y value on the unit circle, and the cosine of any angle is the x value on the unit circle, that since the tangent of any angle is just the y over x, I can replace y with sine and x with cosine to get that the tangent of an angle is equal to the sine of that angle over the cosine of that angle. Right, you just replace. And since cotangent is the reciprocal of tangent, then cosine over sine gives us cotangent, which again should make sense if you look at your first definitions we had written down. Cotangent is x over y. So cosine over sine. The Pythagorean identities might seem new to you and strange, but actually these follow again exactly from those definitions we were using earlier. If I plug in y for sine and x for cosine, you would get y squared plus cosine squared equals 1, right? But the very first thing we wrote down at the start of this whole unit is that for the unit circle, its formula is x squared plus y squared equals 1. And those are the same thing, right? Y squared plus x squared equals 1 is the same thing as x squared plus y squared equals 1. So this Pythagorean identity follows directly from the unit circle. The rest of these two follow directly from this definition as well. If you take your formula here and divide everything by x squared, x squared divided by x squared is 1. Y divided by x is tangent. So y squared divided by x squared would be tangent squared. One divided by x is the reciprocal of cosine, which is secant. So 1 divided by x squared would be secant squared. Similarly, if you divide all of these by y squared, you get x divided by y, which is cotangent. So x squared divided by y squared is cotangent squared. Y squared divided by y squared is just 1. 1 divided by y is the reciprocal of sine, which is cosecant. So 1 divided by y squared would be cosecant squared. So again, all of these identities that I'm giving you are really just manipulating those 6 formulas we started the class with and showing how the different trig functions relate to each other. All right, so do I have any questions about this, or does anyone need more time to write? Okay, then let's do some problems. So basically, there's 2 types of problems that are going to make you use these identities. The first is when they will tell you what one of them is, and then ask you to find the other trig functions from that. To solve this problem, what I want to do is take my angle and see how it relates to the one I'm trying to find. So if I look, what identity relates cosine and sine? And if you look at the list, the only one that has just sine and cosine is your Pythagorean identity. So what I can do then is say, all right, sine squared plus cosine squared is 1. So if I plug in 0.8 for cosine, I'll have sine squared plus 0.8 squared is 1. So then that gives me sine squared plus 0.64 is 1. To get sine by itself, I need to get rid of this squared and the 0.64. So if I subtract 0.64 from both sides, I get 0.36. To get rid of the squared, I would square root, and the square root of 0.36 is 0.6. Technically, I suppose it would be plus or minus 0.36 or 0.6. I guess depending on what quadrant we're talking about. Yeah. All right, to find out what tangent is, again, a similar kind of thing. So what trig function relates tangent to cosine? And you'll see that's this one right here. In order to use this, we have to find out what sine is, but hey, we already did that. So we can write that tangent is sine over cosine. So the tangent of our angle would be 0.6 over 0.8 which if you go ahead and divide through is 0.75. Okay, I'm going to show you one other way I could have done this problem. If you're taking the ACT or you're trying to do this problem and you don't remember your identities, you are not out of the running. Remember that cosine of theta tells you the adjacent over the hypotenuse. So if the cosine of theta is 0.8, that means the adjacent is 0.8, and we could say the hypotenuse is 1. And so then you could recreate a right triangle where this is 0.8 and this is 1, and then use the Pythagorean theorem, a squared plus b squared plus c squared, to find the other length. And then once you have all three sides of a right triangle, you can find all the trig functions, right? Sine would be the opposite over the hypotenuse. Tangent's opposite over adjacent. Cosecant is hypotenuse over opposite, right? So if you ever forget your trig identities, you could solve this problem geometrically by labeling the values they give you, putting them in a right triangle, and then using the Pythagorean theorem to find the missing third side, and you're off to the races. This method will take longer and take up more space to do. So again, this is like only if you don't remember our shortcuts. Okay, is there any questions about this example, or does anyone need more time to write? All right, then it's your turn. If the sine of theta is 0.28, find cosine of tangent. Very similar to the problem we just did. I'll give you 3 minutes. Okay. So, yep, I believe those are right. Anna, you want to help me through this? What trig function could I use to relate sine, or trig identity, could I use to relate sine and cosine?
We can use the same one we did last time under the Pythagorean identities.
That's right. So that we get 0.28 squared plus cosine squared equals 1. 0.28 squared is 0.0784. Equals 1. Subtract. And I will encourage you, try not to round as much as possible when doing these. Every time you round, you're going to mess up your answer. All right, square root. Boop. Square root, second answer. We get exactly 0.96. All right, and then now that I know cosine, what trig function relates sine and tangent?
And just do the same one again under the quotient identities.
That's right. The one nice thing about the way we're doing this now is there's not that many of them. I always say there's not that many of them, but the reciprocal rods, like, just relate to them. Those are pretty straightforward. So there's really only 5 that we're really going to be using a lot. At least in terms of, like, I give you one, tell me what the others are. I will tell you, it does get worse. We get more. We end up filling a whole sheet with the different identities. But if you go ahead and divide those, you get 2.291, repeating. All right, yay. Okay, so I think rather than do another one of these right now, what I would like to do is We'll come back and do more if needed, but I want to make sure we get through some of these proofs first. So let's try a proof now. The one nice thing for your class, though, is these proofs, since they're done in WebAssign, will really have you only fill in like parts that are missing. So you don't end up having to like recreate the entire proof on your own. So how these proofs work is they will tell you that two expressions are equal, and then you need to show using the trig identities how I could get this to equal 1. And it won't always be equal to 1. Sometimes it'll be equal to another trig function. But basically, you just need to manipulate these to convert them from one to the other. There are a lot of different answers for these, so I can't really give you a step-by-step guide on how to do it. But here are your general things you want to look for and do. First is you want to simplify your problems as much as you can. Second is you want to use your Pythagorean identities if you can. That's the first thing I always look for. Can I use a Pythagorean identity? If the answer is no, then what you want to do is you want to convert everything into sine and cosine. Convert to sine and cosine. That's generally how you want to do this. And then once you have things in terms of sine and cosine, hopefully it'll be clearer how you can get to your final goal. So for example, for this first one, I need to convert this into the number 1. Well, it is already simplified. There's not anything I can distribute like in the second problem. There's no like terms, nothing like that. There's no Pythagorean identity I could use. There's no number or trig function squared. So I'm really going to go start with step 3 here. I'm going to convert everything into sine and cosine. Cosine already is cosine. That's great. Secant. How does that relate to sine and cosine? Well, secant is 1 over cosine. So I would do, first step is I would write that this cosine of theta can be multiplied, instead of secant, it can be multiplied by 1 over the cosine of theta. And that's a reciprocal identity. And then once you have it like this, you can see that that is the same thing as cosine over cosine. That's multiplying. And cosine divided by cosine, anything divided by itself is 1. And that's division. So again, when I do these by hand, step by step by step, I like to put what my next line is and the reason how I got that line in parentheses next to it, kind of like you did back in geometry with a 2-column proof. Like, these are my statements and these are the reasons why I know their work. So I know secant can become 1 over cosine because it's a reciprocal identity. I then multiply these together and I divide to get 1, which was my goal. All right. So let's try another one. So again, I want to convert this to equal 1. So for this one, since I do have two things being multiplied together, I'm going to start by simplifying. And I'll actually multiply them together. Secant times secant is secant squared. Secant times negative tangent is negative secant tangent. Tangent times secant is positive secant tangent. Tangent times negative tangent is negative tangent squared. And that's the distributive property. All right, so again, when they give you something like this, where you have some functions being multiplied together, generally you will want to do that to simplify your problem. Because what will happen then is negative secant tangent plus positive secant tangent. Those are opposites. They will, if I add those together, they will cancel out. And I'll be left with secant squared minus tangent squared. And that's combined like terms. Okay, I'll tell you, whenever you're doing these problems and you get a trig function squared, it is like flashing red light. You should be using a Pythagorean identity. It's like a strong hint that a Pythagorean identity will get you where you need to go. So if we look at our Pythagorean identities, you can see that secant squared is 1 plus tangent squared. So I could use that in this problem. So instead of writing secant squared, I can write 1 plus tangent squared minus tangent squared. That's a Pythagorean identity. And now that I've replaced secant squared with its Pythagorean identity, 1 plus tangent squared, you can see that this is going to finish for us pretty nicely. Tangent squared minus tangent squared is 0. So our final answer then is 1, again, by combining like terms, which I abbreviated there as CLT because I ran out of space. Okay, I'm just going to rewrite that. Let's try that. Let's try rewriting that terms. There you go. Look at how well I wrote that. That was all freehand too. Definitely didn't type that in. Okay. So is everyone sufficiently disliking what they're seeing on the screen? Is it pretty awful? Yeah? Good. Good. That's a good place to be at. Because you'll be surprised at how many emails I get from students being like, hey, we haven't really done a lot of proofs since I was in geometry. Can we do some proofs? And I'll be like, yeah, we could do some proofs. Sure. All right. Let's have you try some, and that'll be the end of class. So try these two. You're going to use your identities to try to get this to equal secant. Again, use your identities to try to get this to equal cotangent squared. I'll give you 3 minutes. By the way, at the end of this, the answers vary. So if I end up doing it differently than you, that doesn't mean you did it wrong. All right, let me finish writing these out and then we can talk through it and see if this is what you did. Oh, geez, that's not right. There we go. And I think okay, how do we feel about this? So if you replace tangent with sine over cosine with your quotient identity, Then you replace cosecant with 1 over sine with your reciprocal, and you multiply these together. The sines will cancel out, leaving you with 1 in the numerator and cosine in the denominator. But 1 over cosine is just secant by your reciprocal identity. For the second one, if you distribute it properly, you should get this as your answer. If you combine like terms, the cosecants cancel out. And then cosecant squared is just 1 plus cotangent squared according to the Pythagorean identity. And 1 minus 1 is 0, leaving us with just cotangent squared like we wanted to by combining like terms. Questions, concerns, complaints? And again, I think on the actual homework, it just like has you fill in parts of this. So you don't have to end up doing like the full proof by yourself. All right, this homework is due Monday. Monday, you will probably have a sub. I think you'll definitely have a sub. I won't be able to be in there. But, I mean, you've had a subs before. It's pretty much standard procedure about what you're going to do. I'll post something in Classroom. You'll do that. So then once you have this done being written into your notes, you should head off to 7th hour. Have a good one, everybody. If you run into any issues, feel free to send me an email, and I'll help you out.
See ya.
Bye.